All right, so that's the setup, and that's our formula, main formula. Let's do an example. The example that I'm going to take is the one that we did at the end of last time, or near the end of last time, which was this formula here, r is equal to 2a cosine theta. Remember, that was the same as x minus a squared plus y squared equals a squared. So this is what we did last time. We connected this rectangular representation to that polar representation. And the picture is of a circle, all right, where this is the point 2a comma 0. All right, so let's figure out what the area is. Well, first of all, we have to figure out, when we sweep out the area, we have to realize that we only go from minus pi over 2 to pi over 2. So that's something we can get from the picture. You can also get it directly from this formula if you realize that cosine is positive in this range here, and at the ends, it's 0. So the thing encloses a region at these ends. So at the ends, cosine of plus or minus pi over 2 is equal to 0. That's what cinches this up like a little sack, if you like. All right, so the area is now going to be the integral from minus pi over 2 to pi over 2 of a half times the square of r, that's 2a cosine theta squared d theta. Question?
How do you know from looking at the picture that you're going from negative pi over 2 to pi over 2?
How do I know from looking at the picture that I'm going from negative pi over 2 to pi over 2 is the question. I do it very, like with my whole body. I say, here I am pointing down, that's negative pi over 2. I sweep up, that's 0, and I get all the way up to here, that's pi over 2. So that's the way I do it. That's really the way I do it. I'm being honest. Now, if you're a machine, you can't actually look, and you don't have a body, so you can't point your arms. Then you would have to go by the formulas, and you'd have to actually use something like this formula here. The fact that this is where the loop cinches up. This is where the radius comes into 0 at pi over 2. So you need to know that in order to understand the range. All right? Another question.
So when we're doing these, should we just guess that it's going to be a loop, so the course is going to be 0?
So when we're doing these, should we just guess that it's going to be a loop? I'm probably going to give you some clues as to what's going on because it's very hard to figure these things out. Sometimes it'll be bounded by one curve and another curve, and I'll say it's the thing in between those two curves. That's the kind of thing that I could do. Here, you really should know this one in advance. This is by far the most, or this is one of the typical cases anyway. I'm going to give you a couple more examples. Don't get too worked up over this. You will somehow be able to visualize it. I'll give you some examples to help you out with it later. All right, so here's the situation. Here's my integral. And now we're faced with a trig integral, which we have to remember how to do. Now the trig integral here, so first let me factor out the constants. This is 4a squared divided by 2, so it's 2a squared, integral from minus pi over 2 cosine squared theta d theta. And now you have to remember what you're supposed to do at this point. So think, if you haven't done it yet, this is practice you need to do. This trig integral is handled by a double angle formula. As it happens, I'm going to be giving you these formulas on the review sheet. You'll see they're written on the review sheet, at least in some form. So for example, there's a formula, right, and this will be on the exam too. So this is the correct formula to use here is that this is 1 plus cosine 2 theta divided by 2 d theta. So that's the substitution that you use for the cosine squared in order to integrate it. That serves as a little review of trig integrals. And now this is quite easy, all right? This integral now is easy. Why is it easy? Well, because it's the antiderivative of a constant, and cosine 2 theta, it's antiderivative you're supposed to be able to write down. So the antiderivative of 1 is theta, and the antiderivative of the cosine is half the sine when it's 2 theta. All right? And that is a squared times pi over 2 minus pi over 2. And the signs go away because they're both 0. So all told, we get pi a squared, which is certainly what we would like it to be. It's the area of the circle.